Alright, we're going to start to go a little bit more in depth with what we know about functions. So we've talked a little bit about plotting points onto a graph, something like that, a coordinate plane. And now we're going to just look a little bit more in depth with what a function is. So a function is a relationship between inputs and outputs. So it's a compilation of different points that show us a relationship. So when you put an input into a function, you get one output. And there are three ways to show a function. So the first one would be right here. An equation is one way that we can show a function. The equation could be as simple as y equals x. It could be y equals x squared plus 2. And it could be many different things. But those are all examples of a function. So it can be an equation. Another possibility is for it to be a table of values. So for instance, we have this table down here, which is sometimes what it looks like. Sometimes it will just look like an x and a y. And you know that if you put an x into the function and you say it's -3, then the y is 1. Or if you put 0 into the function, your y would be 2. And so on. So it can be also a table of values. And then the third and final way that we can represent a function is a graph. So we can always put our function on a coordinate plane, and sometimes a function may look like that. Sometimes it may look like this. Some even look like that. And we'll learn about all those this year. So yeah, those are the three different ways to show a function. And we're going to be able to see in example 1 that we can take an equation, find values for the table, and then be able to plot it on a graph. So there's always an input in a function, and that's an x value. So the input, also known as the independent variable, is the x value. And that doesn't depend on anything because it's the first thing that we put into the function. We can put anything into it. And then let's take this one for example, y equals -5x plus 2. Once we put this x into our machine here, that's supposed to be like a machine, the machine we're putting it through is -5x plus 2. So we're taking this x, putting it into the function rule, and from that we get out a y value. And the y would be the output is the dependent variable. And that's the y value. So that may seem like a lot right now, but basically we're taking an x value in, putting it through a machine, and then getting out a y value. A real life example would be like our input, say this is a toaster. If I could draw a toaster, I would. And the input is a piece of bread. So that's a piece of untoasted bread. The output would be the piece of toasted bread. So that's sort of one way to explain it, but basically functions are like machines in that you put something in and you get something out. So let's look at example 1. We have an equation y equals -5x plus 2, And we're going to put in some inputs or some x values and see what we get for y values. So for our x values here, we're going to choose 5 of them, and they can be any of these values along the x-axis. So it could be -6, -5, -4, -3, -2, -1, 0, 1, 2, and so on. So let's start. I always like to have 0 be in the middle. So we're always going to want to do that one because normally we can see quite a bit about a graph if we put in the 0. And then I just like to do these 5 values right here. So -2, I want to plug that into this and see what happens. -1, 0, 1, and 2. Alright, so starting with -2, and our function is y equals -5x plus 2. So we know that y equals -5 times our x. So times the x value that we're putting into it, which is -2, and then plus 2. So now we know that y is equal to whatever that is. And thankfully, from our first lesson in this chapter, we know how to solve that. That's -5 times -2 plus 2. So we're following the order of operations. -5 times -2 is +10, plus 2 is 12. So what we have now is the start of a table of values. We know that -2, 12, that's a point. This could be written like this. Oops. -2, 12 as a coordinate point. And that's basically what we got from doing that little bit there. And we could try to plot that on the graph. If we go -2, 12, there's going to be a point right about up there. So that's another reason that it's good to keep stuff toward the center here. Let's try -1. I believe that's going to land on our coordinate plane there. So we've got y equals -5 times -1 plus 2. So -5 times -1 is +5, plus 2 is 7. So we have another point at -1, 7. So that one actually is going to hit. So we go -1, up 7, and we're going to have a point right there. So that's our first point that we know we have. Alright, let's try 0. We've got y, change my size there, y equals -5 times 0 plus 2. And what's -5 times 0? Well, that just leaves us with 0 plus 2 is 2. So we have another point at 0, 2. So we can kind of fill in our table of values there. And we've got a point at 0. So 0 left and right. We're not going anywhere that way, but we are going up 2. So 0, 2 is our next point there. Alright. Last couple ones. We've got y equals -5 times +1 plus 2. Well, negative times a positive is negative, so we have -5 plus 2 leaves us with -3. So we have a point at 1, -3. And then the last one, 2. So y equals -5 times 2, which is negative 10, plus 2 is negative 8. So filling in my values as I go, we got 2, negative 8. So we know we have another point at 2, negative 8, and we could write coordinate pairs like that for all of them if we wanted to, just to keep it straight. And we go 2, negative 8 is going to be a point about right there. And so you're almost done. We've come up with an entire table of values from our equation. And we know that we've got our equation, we have our table. We can also get a graph from those, and that's what we've been working on over here. So I'll draw a line through our points because we always want to do that. Once we plot some points, we want to draw our line showing about where those go. There's going to be an arrow on both ends because think our first value was negative 2, positive 12, which is up there. So there's even a point up there. Even though we stopped drawing our graph, it still goes on forever. This line, if we wanted to, we could continue it all the way off the page, but we just draw an arrow at the end of it to say that. So quite a bit in that lesson. We're going to do a couple more examples together in the next video, and hopefully you'll be feeling pretty good about it by the end of that.